Today we just discuss about a line coding technique. It's a process of converting your digital data into signals. Let us see why this conversion is required. When you deal about more than one data format to be transmitted, we need to convert it into signals. For that, we need to have a special procedure or the special coding technique called a line coding. Let us take a multimedia data. Basically it is a combination of text, images, sound, video, and animation. Each one will be differently. Different. It will be stored in a different format. If we take a text data, it will be stored in a document, and if we take animation, if we take images will be stored in a JPEG, and sound will be stored in a SND. There are so many different formats are there. So when we combine and send it as a multimedia data, we need to convert by means of line coding. So that technique will have it as a line coding technique. Let us see the 5 bits are taken in this example. Line coding is applied, and then you could see the digital signal will be like this. So when you take this digital signal, there are 2 bits. It consists of only zeros and ones, binary bits only. 0 is always used for low value representation, and 1 is used for high value representation. Let us see the line coding schemes. In the line coding schemes, we can have 5 different types. One is a unipolar, polar, bipolar, multi-level, and multi-transition. Let us see what are the abbreviations we have used here. That is NRZ is a non-zero return to, non-return to zero, non-return 0, and R is return to 0, and then AM is amplitude mark inversion, and PAM is a pulse amplitude modulation. MLT3 is a multi-level link transmit, which uses 100 Mbps, and then it supports for maximum 32 megahertz. Let us see bipolar schemes. Mainly, this bipolar schemes uses the 3 voltage levels: 0, positive, and negative. 0 is used always for the low value representation, and while the high value representation will be taken as alternative between the positive and negative, because there are 2 binary digits are going to be used in the representation. One is 0, another one is 1, and 0 is used for always the low level, it is fixed, and then the 1 will be represented positive and negative values of signal levels, positive and negative values of signal levels. There are 2 bipolar schemes are there. One is the bipolar NRZ, another one is the bipolar RZ. Let us see how it looks like and how it is reacts and represented by means of the signals. Let us take the data 1 0 1 0 0 1 1 and 0. So bipolar NRZ will look like this, because it will not return to 0, and bipolar RZ will return to 0. If we take a type, the classifications of bipolar encoding, there are 3 different types are there. One is the AMI, B8ZS, HD, B3. So what is AMI? AMI is nothing but it is amplitude mark inversion. It defines one inversion. It defines one alternate inversion. So it uses the 0 bit by 0 levels always, but the bit is described by rotating the positive and negative voltages. It also be referred as pseudo-ternary because the binary 0 alternates between positive and negative values. By reversing each appearance of 1, the bipolar AMI achieves 2 things. The DC component is 0 and the second stays synchronized. So how the synchronization will be happening, only the one level, that is the position of the 1 will be changes alternatively, but the 0 will always be represented and have got the same meaning till the end of the signal. Okay, till the end of the value bits are getting over. Let us see the example for bipolar AMI coding. We have taken the 8-bit code as 01001110. So the 0, as per this AMI is concerned, 0 is always will have a base value, and it is a minimum. To represent the minimum, it is used, and then the 1 values are representing positive and negative alternatively. So the first position of the 1 will be the maximum, that is a positive value, and the next consecutive zeros will be represented as no change at all, and then the next one presence is represented by negative, and the next consecutive one is represented by positive. Likewise it goes. So the bipolar AMI encoding will take the zero, I mean the low level zero will be remain constantly for representation, and one position will be taken positive and negative alternatively. Next one is B8ZS bipolar. It is the abbreviation is a bipolar 80 substitution, which takes the 8 bits to represent bit stream to represent. So this is identical to bipolar AMI, but bipolar will be using the two conditions. One is 0 is used for always the low value, and then the ones will be represented for positive and negative alternatively. But here 8 or more consecutive zeros are encountered in the data stream. The design depends on the polarity of the previous one is the same. One is the same, that is occurring just before 8 zeros. You could see that the data consists of how many bits are there? 11 bits are there. So the out of which what we have to consider is positive, because it uses the different pattern. You could see the pattern here. The substitute 8 consecutive zeros with the 00 VB 0 VB. So the meaning is the first 3 positions are considered as a low, and the second position is the fourth position is considered as V for violation of the encoding rule, and B for bipolar happens. It implements the bipolar line coding rule here, and then 0 VB. So 00, 0 VB and 0 VB is the pattern used in the B8ZS. So the B8, why this 8 is called? Because it considered only the 8 data bit stream. And the pattern used is 00, 0, 0 VB, 0 VB. Let us see how the signals will be. It consider only the previous level is positive or negative. So if we take this 2 cases of B8ZS scrambling technique, we have used that 9-bit. We have taken the 9-bit values. The first one is 1. It is a positive, and then the 3 zeros there is no change at all. And the fourth position, it violates because 00 VB. So it violates position, and then the B for the bipolar will happen here, and then 0 and violates, and then bipolar positive value. Bipolar positive value. Okay. So the previous level is positive. The previous level is positive. It happens. It uses 00 VB, and then the 00 that is 000 VB, and then the 0 VB, right? That pattern will be used here, and then the previous level is negative. There are 2 cases has been discussed here. One is a positive value, another one is a negative value. If it is negative in the sense, it uses the rule that B stands for bipolar. That is, it uses that bipolar value here, and then it uses the 3 zeros as the minimum value. Then it violates. Then it takes the bipolar value. Then it assumes that it violates, and then bipolar value. So altogether, you have to remember this 00 VB and 0 VB is the pattern which is used for this B8ZS. The encoding will happen based on the polarity of the previous bit. The polarity of the previous bit is positive here. So if at all it is positive in the sense, which will be changing in terms of 3 bits as a low value, and then change occurs, and then the violation happens, and then the change occurs, and then the violation happens, and then positive value. So why this violation happens, like violations happens because of that positive and negative based on the polarity of the previous digit, whether it is positive or negative. And then if we take a next example, the polarity of the previous bit is negative. It starts with the negative, and it is followed by the 8 0 bits. So it has to be changed in terms of the polarity of the previous bit. Let us take the first violation as a 0. This is violation, so 0, that is negative. And then the 3 0 bits are there, and then the negative and 0 and plus. How it is plus? Yeah, this is a bit, this is binary, and then the violation, and then the last one is your violation. Okay, so the violation period, this pattern is strictly followed by based on the polarity of the previous bit. Let us take a HDB3. HDB3 is the high density polarity. In blank of 8 zeros, there are two cases, either the polarity of 1 before 0 is positive or negative, then the solution of the both cases will be as follows. Let us take a 8-bit value and assume that the positive value we are going to take. The positive value as taken as a, I mean, it's going to be the polarity, and then the 0 0 0, and then the 1 bit is plus. I mean, this polarity, this is violation. How it is violation? No, because each and every one, like because different methods, encoding techniques, which will use the different patterns. As we see in the bipolar technique, I mean B8ZS, here we have a different technique, that is 00V or B00V, where the same meaning here also. V is used for violation and B is used for bipolar. So based on this, it has been applied that the first position, the previous position of the 0 bit is plus, it is going to the violation, and again this is also violation, and this is also violation because if it is negative. This 0 will be taking the previous bit value, and we have two patterns. We are following the two patterns. Based on it, it is replaced with 0. So let us see how the first substitution and second substitution, third substitution goes. So the same pattern is going to be followed because one is the high level and low level, but the even number, even 0 is applied here. What is the first position? What is the bit used here? 000B or B00V depends on the number of non-zero pulses after the last substitution. If the non-zero pulses is even, the substitution is B00V to make the total of non-zero pulse even. And if it is negative in the sense, negative, if the pulse is odd, we need to have a 00V to make the total of non-zero pulses. So based on it, the first substitution will take a 4-digit, that is 000V. The first one is your polar. Why it is polar? Because it is even, and again it is a even. So the second one is, I mean, the last position is also a even. So the first position is B00V. The pattern has been used. Okay, why this pattern has been used? Because non-zero pulses is even, the substitution B00V to make the total number of non-zero pulses. So similarly, odd. Odd in the sense you have to use only the second method, second formality, that is 00V. So that will be used here, 00V. So similarly, the third substitution will be the combination of these two, that is B00V, that hasn't been shown here. But anyway, you just take the 4-bit. 4-bit will be used in the format of B00V. So first position is B and second position is 00, and then third position is B. Thank you.